Okay, now this is the summary of lab number 8, which is actually lab number 9 from the student manual. That is about the sound input. So these transducers or these instruments, or basically these things, convert sound waves or sound energy into electrical energy. So we studied two different sensors. First one is microphone and second one is ultrasonic sensor. The assembly of microphone or dynamic microphone is quite simple. It has a diaphragm along with an oscillating coil, moving coil or oscillating coil placed between the magnets. The placement of the magnets can be different so as to maximize the output. So what basically happens is the sound wave strikes the diaphragm and diaphragm vibrates, which also then oscillates the coil. So when the coil oscillates between the magnets, motional EMF is produced. Then the emotional EMF is amplified through an instrumentation amplifier or differential amplifier. It's up to you to decide, and then again another amplifier if the output is not readable. The number of amplifier or the gain of the amplifier depends upon you. If you think that the output is considerable or readable, then you don't need to amplify it. If you think that the output is not quite readable, then you need an amplifier. So as you know that the output in this case is in AC, and we don't have an AC voltmeter in our trainer, so we will rectify it. So after amplification it is rectified and then displayed on the and measured on the voltmeter, and as well as displayed on the bar graph display. So this is the microphone. So you have simply connected an AC amplifier instead of instrumentation amplifier, because there was only one node given. Second node was already grounded. Then as I said, you need to rectify it. So we have rectified it and then connected two amplifiers. Again, I'm saying it's up to you to decide whether you need one amplifier, two amplifier, or not a single amplifier. So see, when sound wave strikes, the output can be observed on the LED bar graph and on the voltmeter as well. See? So, and this was the first one. Now coming towards the second sound sensor, that is ultrasonic receiver and transmitter. There are some materials, some ceramic material. When you press such materials or such crystals, the output appeared in the form of an electrical signal. Such materials are piezoelectric material. So when such type of material, such a crystal vibrates, it produces an electrical EMF or electrical signal or electrical voltage. So it consists of two assemblies. First one for the receiver or for the receiving side, and second one for the transmitting side. In the receiving side, the ultrasonic wave strikes the material vibrates and produces an electrical signal in the form of an AC. So in the receiving part, ultrasonic sensor, we need an ultrasonic sensor, we need ultrasonic sound. The ultrasonic sound strikes the diaphragm of the receiver. The diaphragm is attached to the crystals. The crystal vibrates and produce electrical signal, and the electrical signal can be measured through the voltmeter. On the transmitter side, we have same crystal. This phenomena can take place in reverse too. For example, if vibrations are converted into electrical signal, then electrical signal, if applied to the same crystals, the crystal begins to vibrate. So input in the form of AC signal is given to the crystal. Crystal vibrates. The vibrating crystal strikes with the diaphragm and produce sound waves. As the input is given of around 40 kilohertz frequency, so the output is also of around 40 kilohertz. So as you know that 40 kilohertz comes in the ultrasonic range, which we can't hear. So this was the simple assembly. In this assembly, what will happen, the moment you connect the input here, the output will begin to produce, because transmitter and receiver are placed in front of each other, while the assembly on the trainer is not like that. The receiver and transmitter both are facing upward. So when the input is given to the transmitter, output will not be produced unless the sound strikes to some obstacle and returns back to the receiver. So this assembly has many applications. Therefore, ultrasonic sensors are always available in this type of assembly. So let's make it. You need an input. You need to give its transmitter the input from the oscillator. Where is the oscillator? This one. And then the output is first amplified. Output from the receiver is first amplified, and then it's filtered, and then rectified, see. So you just need to calibrate and adjust the amplifiers, which I think you know very well. So the assembly here again was very simple. So see, the output is first amplified, and then filtered, and then rectified, and then amplified again, and is measured through the voltmeter and displayed on the LED bar graph as well. So see, when there is no obstacle in the range of ultrasonic sensor, no output is produced. When the obstacle cuts the sound, ultrasonic sound, the output will begin to produce. See, so basically what is happening here, the sound waves are striking my hand, and then they are reflecting back to the receiver, and then receiver is converted the sound waves into an electrical signal, which is displayed here. So this was all about the sound sensors.